Okay, it's recorded now. Saya buka whiteboard je. Okay, patut boleh nampak skrin saya. Lama.
Nampak Ustaz.
Okay, thank you. Sekejap, ada soalan yang tak ada ni. Sekejap, saya cari soalan je. Mungkin saya terlupa masukkan soalan dekat slide. Sebentar. Saya letak dekat assessment. Okay, bagi saya buka slide lama dulu. Kita nak tengok soalan. Okay. Proof techniques. Okay, present now. Alright, mathematical induction, there are three major steps. The first step is try to prove the first case right. Okay, nak ingat kembali ya. The first, the element of n is correct. The second step is we assume that the case is correct for some k, n equals to k. And then by using assumption from step 2, you try to prove that the case of n equals to k plus 1 is true. Yang step 4 tu hanya conclusion, tapi conclusion wajib letak. So dia 3 major step, yang last tu hanyalah conclusion. Sekarang ni kita nak cuba jawab beberapa contoh soalan. Kita exercise dan saya sambil tunjuk. Okay, saya akan expand sambil screen ni. Kalau ada apa-apa minta jangan tulis dalam chat. Kalau saya tak ni minta bersuara. Okay, kalau tak faham. Okay, saya akan buka. Kita cuba tengok. Okay, the first question, just to refresh yourself, you need to prove by using the mathematical induction that the sum of 1 squared plus 2 squared plus 3 squared plus blah 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 plus n squared equals to n plus 1, 2n plus 1 over 6. Okay. Okay, recall that, alamak ni soalan lain. Okay, for every n which is a positive integer, domain plays a huge role here. Sometimes the domain is different, therefore the formula on the right hand side will be sometimes different. So make sure you got the domain correct. So what is the first element of positive integer? Will be the first element of positive integer. N equals to 1. Hati-hati jangan letak kosong. Kalau letak kosong dia mungkin boleh dapat jawapan yang lain lah. Kita kena sensitif dekat domain sini. So n equals to 1. Right now we have the equality here. We have right hand side for this one and the left hand side. So for step 1, kita ambil n squared. N equals to 1, n squared equals to 1 squared sama dengan 1. Settle for the left hand side. For the right hand side, n equals to 1, you masuklah 1 plus 1 plus 1, 2, 1 plus 1 over 6. Okay, saja peringatan bracket membantu kamu untuk buat kesilapan algebra. Saya suka letak bracket. Sebab ada student yang tak letak bracket, dia akan kira salah je kat situ. Okay. So, berapakah dia? 2, 3 per 6 equals to 6 over 6 becomes 1. So, for the case of n equals to 1, or the first n element, n naught, the left hand side equals to right hand side for n naught equals to 1. Yang ni saya tak kisah sangat ada yang letak P ke tak letak P, tapi dia betul. Yang memang saya nak tengok betul-betul ialah student berjaya menggunakan formula from the left hand side and the right hand side correctly. And you must show step by step. If you don't show step by step, contohnya ada setengah student dia pandai tau. Dia tahu last kali dia kena sama, apa yang dia buat? Ini jawapan yang saya tak terima For the ni for step 1 again n not equals to 1. Okay, dia buatlah left hand side n equals to square sama dengan 1 square sama dengan 1 sebab senang. Right hand side pula dia tulis right hand side equals to 1. Suddenly he managed to get the left hand side, right hand side dia cakap sama. Okay, for this one, your right hand side tak akan dapat sembarang markah because you don't apply to the formula of right hand side. You just happen to skip the step. You don't do the calculation of applying the formula of the right hand side. Therefore, this one I will not accept for the right one. So make sure you apply into the formula line by line by a valid substitution of the value of n naught. Step 1, student jarang salah. Sebab senang. Step 3, ramai orang buat ngelak ni. Dia ramai skip yang ni for right hand side. Pun tak boleh skip Dia kena tunjuk step by a valid substitution. Okay, we proceed to step 2. Alamak, ni nota lain. Sekejap Alright, for step 2, you need to assume that n equals to k is true. You don't prove anything, but you need to assume that 1 squared plus 2 squared plus 3 squared plus n squared. Okay, this time n equals to k, so you substitute n with k. K squared sama dengan k plus 1, 2k plus 1 over 6. So the step 2 is done here. That's all. You need to substitute n equals to k. And don't think this is just a simple tulis-tulis. Memang nanti kamu akan guna step 2 ni. Saya padamlah yang ni. Saya buat nota semalam untuk subjek lain. Soalan untuk subjek lain. Okay. How to apply step 3? Step 3, you need to prove n equals to k plus 1 is true. Okay, right now by using step 2, you dah tengok dah compare kat atas ni. Kalau atas is k squared, bawah dia jadi apa? Saya suka tengok dia sebagai panduan. 1 squared plus 2 squared plus 3 squared plus okay, you will arrive first at k squared. After k will be the term of k plus 1 squared. You see? The second step until k, the third step sampai k, lepas tu k plus 1 lagi. you need to show that it will exhibit the same value as yang kanan pula. Ni K. Yang bawah ni dia jadi K plus 1. K plus 1. You plus 1. Yang ni yang kena hati-hati. Tu kurungan, saya suka buat kurungan K plus 1 plus 1. Tutup. Over 6. Okay. Now, we start with the left hand side. You might start with the right hand side first. There's no problem on that. Kalau kita mula on the right hand side first, you akan dapat dia jadi K plus 1, K plus 2,
2K plus 3 over 6.
Thank you. Senang saya. Terima kasih. Dia akan jadi yang ni. The idea on how to show left hand side becomes the right hand side. Right now the left hand side is nothing like the right hand side. Therefore by using assumption 2, assumption 2 cakap yang ni sampai sini sampai K squared equals to K plus 1 to K plus 1 over 6 plus K plus 1 squared sama. Ayah. Alright. Now by using your algebra capability, try to show that it will be the same. Kat sini yang saya kata ramai orang ngelak tu sikit. Dia buat macam ni, lepas tu tiba-tiba next step terus sama. Terus tiba-tiba. Macam ni tak logik lah. How can I know from here to here directly? Pelik lah. Kalau student buat macam ni, saya tak bagi markah untuk left hand side. Sebab dia tak valid. Dia tak show by using a valid process. Dia cuma tahu akan sama je, dia terus tulis sama. Saya tak akan terima. Maka cuba guna kemahiran algebra. Left hand side ni K plus 1 to K plus 1. Saya jadikan 6K plus 1 squared over 6. Okey, kat sini saya nampak saya boleh keluarkan K plus 1. Jadi 6K plus 1 tambah K 2K plus 1. Saya keluarkan K plus 1 is the common factor there over 6. Proceed K plus 1. Ni buka saya buka 6K plus 6 plus 2K squared plus K over 6. Then become K plus 1. 2K squared plus 7K plus 6 over 6. Now I need to factorize this. K plus 1 becomes 2K plus 3, jap saya test. 3 silang. K plus 2, betul ke? 4K plus 7K, betul. Over 6. At this time, then you can see that it is similar to the right hand side. Sekejap saya padam. Right now it's similar. Left hand side is equal to the right hand side. Therefore, left hand side equals to right hand side for P n equals to K plus 1 is true. Okay, from step 1 until step 3. And don't forget the conclusion. The large conclusion is that by using mathematical induction, What did you just prove just now is that 1 squared plus 2 squared plus 3 squared, if you add up until the n squared, it will be n plus 1, 2n plus 1 over 6 is true for every positive integer. Okay, try to retrace back my step. Okay, step 1, show the first base case is correct. Assume it is correct for n equals to k for step 2. And by using step 2, you show that the left hand side equals to right hand side for the case of n equals to k plus 1. Okay. Ada soalan common daripada student ialah the student will ask me is that they have a hard time of factorization. Therefore, can they use the expansion? Expansion tu maksudnya macam ni. Dia kat sini dia tak tahu nak faktor, dia darab semua kat dalam, maka dia biarkan dia jadi sesuatu sebegini. K squared plus K squared 2K plus 3K plus 2. Lepas tu dia darab lagi dengan 2K plus 3. Dia jadi cubic equation dia. So dia akan tunjuk yang ni, kalau you dah expand kat sini on the left hand side, right hand side pun you kena expand juga bagi tunjuk dia sama. Ada setengah student dia expand sampai habis jadi K cube plus something K squared. Boleh buat, tak ada masalah. Tapi saya nak tengok kalau kiri you expand, yang kanan pun you kena expand by a valid process that you will be the same. Okay, ada soalan setakat ni? Okay, kalau tak ada. Okay, let's try to appreciate after we manage to prove that the formula is correct for every positive integer. How to use it? Okay, for example, if I ask a very simple question which is find the sum of 1 squared plus 2 squared plus 3 squared. You add up until, I make it a little bit more challenging, 100 squared. Of course, you can use a calculator to find this manually. You letak dalam calculator 1 plus 4 plus 9 plus 20, 16 plus 25 plus ni sampai 100. You boleh. Tetapi you akan ambil masa yang panjang. Right now, we already have this formula. Okay, and this formula can help you calculate it much faster. So, in this summation, for this question, what will be your n?
100.
Yeah, correct. N squared equals to 100 squared. Okay, saja saya tunjuk step by step. Thank you for answering. If n squared equals to 100 squared, therefore your n will be 100. Jangan masuk 100 squared pula. Ada setengah student dia letak 100 squared. Actually, the n is 100. The nth term, sebutan yang ke 100. Masuk dalam formula. Hundred plus 1, 2 times 100 plus 1 over 6. Becomes 100, 101, 201 suppose, over 6. Yang ni you boleh masuk kalkulator, dapat jawapan dia.
338,350.
Pelan-pelan.
338,350.
350.
Yes.
Thank you. Okay, I hope the others also try it. You should get the same answer. As it is true for every positive integer, it's also true for n equals to 100. And very fast to get it. Right now, I ask you to prove number 3. Number 3 dia pendek sikit, number 2 panjang. Okay, for number 3. Proof by using mathematical induction is that the summation of 1 plus 3 plus 5 plus until 2n minus 1 is indeed n squared for every positive integer. Kepada yang baru WhatsApp personal saya ni, dia baru boleh masuk kelas ni, tak apa, saya tak kisah. Tak kisah. Saya bukannya macam setengah lecturer lain yang sikit-sikit nak marah pasal benda yang tak berasas. Saya bukan kata saya bukan garang, saya garang. Tapi bukannya untuk benda macam ni. I believe that the person who just entered my lecture, who I don't know who, has a problem. And I trust you because you have indeed a problem. So don't jeopardize my trust, that's all. Alright. Cuba. Step 1 until step 3. Saya beri masa, ni soalan ni agak pendek untuk step 3 dia. 5 minit boleh Tak sampai 5 minit Cuba guna kaedah step 1 until step 3. Try to prove that it is true. Then, I want you to help me to find the sum of 1 plus 3 plus 5 plus until ni tahun berapa tahun 2020, so tak boleh. 1001 lah. 1001 malam. Okey, yang dah dapat jawab, hello saya. Saya nak tengok kalau ada orang tanya dalam chat. Okey, thank you. Alright. Teruskan menjawab, saya buka in case kalau ada chat. 5 minit. Ni seorang lagi student, saya ada masalah internet connection. Like I said, I know. Saya pun pernah ada masalah internet. You don't need to apologize so much. Saya nampak ni je, apa ni, kesian dia. Okay, kepada yang ada masalah internet tu nanti oh, dia tak dengar saya cakap. Saya kena WhatsApp dia. It's okay. Guna handphone ke laptop. Masalah internet akan memberi masalah kepada student tersebut jika assessment. So assessment tu minta cari internet. Okay, pergilah ke pusat internet, ke cyber cafe ke, ada lagi ke cyber cafe? Tak pun pergi travel, pergi MACD ke, kalau kamu bukan dekat kawasan CMCO, tukar data plan ke, pindah rumah ke, I don't know, you must try it. Saya pernah cerita kat korang, saya pernah drive sampai keluar daripada kawasan berapa kilometer hanya untuk cari internet pasal kena masuk dalam meeting. That's normal. My boss pun tak tanya. Dia tak tanya, Adam ada internet ke? Tak ada, dia akan tanya. Adam, you kat mana? Tu je dia nak tahu. They don't care. It's our responsibility to find it. Dah dapat ke belum? Tak sampai 5 minit lagi. Baru 3 minit. Kena tengok siapa dapat dulu. Saya tak nak bagi hadiah. Ya, tu question dia. Proof and you find the sum. Ya, saya tunggu jawapan daripada student bukannya saya akan bagi jawapan kali ni. You can show it, you can explain it if you want to. I just want to see the student's answer. Tak kisah dalam WhatsApp atau dalam chat ini. Saya nak tengok. Aduh. Udah ke? Sorry, saya bosan. Lepas siap lecture ni nak kena ready pula untuk esok. Dan juga kelas petang ni. Ada tak yang selain Mohsin dapat? Sebab kelas ni bukan Mohsin je. Abang Tajuk nak cuba? Oh, diam. Siapa ni? Lok Jiaji nak cuba? Ataupun Aisyah? Saya bukan macam Dr. Saimi. Dr. Saimi dia suka panggil nama seorang-seorang kalau tak silap saya. Saya tak boleh jadi macam dia. Nak jadi macam dia. Okey, Aida, apa jawapan dia?
Kejar sikit lagi.
Sikit lagi. Jadi taktik Dr. Saimi. Okey. Dah siap. Okey, terima kasih Akram. Boleh tunjuk jawapan dia? Boleh snap ke, tunjuk dalam WhatsApp ke, saya nak tengok, boleh? Jangan malulah. Sporting lah Akram ni. Ada orang dah hantar jawapan. Janganlah hantar personal kok. Hantarlah dalam geruk. Dah ni seorang lagi malu ni. Tapi perempuan expected kot. Jangan malulah, kita nak belajar. Alright, saya komen yang student perempuan ni bagi kat saya dulu. Step 1 betul. Senang kan? Dia cepat je kan soalan ni. 2k plus 1, k squared plus 2k plus 1, k plus 1 lah. Okay, thank you. Yang malu tu. Arisha, kamu betul? Tania? Akram pun satu K squared kalau K squared K plus squared plus squared. Oh, Akram jangan lupa letak conclusion ada tak? Oh, ada. Okay, thank you. By using mathematical induction, okay. Oh man. Akram, soalan 1 tambah 3 tambah 5 sampai 1001. Saya tunjuk balik soalan. 1001. Bukan sampai 100. So, soalan tu Akram baiki. Soalan sum tu, ni 1001. Arisha ada jawab tak? Sum belum. Okay, dia belum. Leong Tenman, thank you. Leong Tenman pun betul rasanya. Saya tengok simbal lalu ni. Very good, you are correct. But please find the sum as well. Tolong cari sum juga, Leong. Sebab selalu student dia salah dekat sini, sum ni. Dia tak tahu nak apply kat 2n-1. Oh, okay. Alright. Jawapannya salah, Akram. Akram bagi sum. Sum kamu salah. Kenapa? Cuba fikir. Aizat Haikal, careless mistake di situ. Idea dah betul. Careless mistake kat sana. Cuba check apa yang kamu salah. Ni yang saya suka kalau ada orang bagi jawapan ni. Aizat Haikal, check balik. Okay. Dan akhirnya ada seorang yang betul. Pemenang dia, yang mana saya tak mau bagi hadiah. Sum dia ialah $251,001. Nak hadiah saya kata tak ada hadiah. Okay. Nak hadiah apa? Hadiah apa? Alright. Sebelum saya tak tahu nak bagi hadiah benda. Dan saya kata tak nak bagi hadiah. Tapi kita tengok step balik. Please recall back the step. Okay. For the first one, some of the students get it correctly. Thank you. You are very cooperative. Betul. Kenapa tak boleh zoom out ni? Alright. Saya tulis balik. The question will be the summation of odd numbers up until 2n-1 is equal to n squared for n which is a positive integer. First step tak ada masalah. Tetapi first step yang manakah adalah left hand side, n not equal to 1. First step. So left hand side, saya tulis balik yang korang nak buat. 2n-1 2(1 - 1) equals to 1. Left hand side. For the right hand side, n not equals to 1. This time is n squared. So n squared equals to 1 squared equals to 1. Left hand side equals to right hand side for the case of n not equals to 1. So for the second one, you just assume that the summation of 1 plus 3 plus 5 until 2k minus 1 equals to k squared. Pun tak ada masalah ini. For the third one, I show. For the third one, 1 plus 3 plus 5 plus, you will arrive at here first, 2k minus 1. You plus 2k plus 1 minus 1. It should be k plus 1 squared. Okay. So because this is k squared, you add up with 2k. Saya nak step by step. Okay, for the left hand side, you can get k squared plus 2k plus 2 minus 1, it becomes k squared plus 2k plus 1. Right now, it's not similar yet, but if you factorize it, it will become k plus 1, k plus 1. Simplified, it is k plus 1 squared. Then, left-hand side equals to right-hand side for n equals to k plus 1. Very good. So, for the conclusion, by using mathematical induction, what you prove is that the summation of 1 plus 3 plus 5 until a certain odd integers is indeed n squared for every positive integer. So how to apply the formula again? The question asks you to find the sum up until 1001. What will it be? So for this case, you must look at this one first, 2n minus 1. You must let 2n minus 1 equals to 1001. N becomes 1001 plus 1 over 2, then n equals to 501. So actually the 1001 is the 501th term. And because the summation from 1 until 1 equals to 501 squared, dapatlah jawapan yang macam Syaza dapat. Saya tak masuk kalkulator. Saya harap kamu letak betul 001. Okay. Well done. Ada soalan tak setakat ni? Okay, so a key point is to ponder for mathematical induction. It's not hard if you will remember the steps and then on how to utilize the step 2 into step 3 tu yang penting. For this particular mathematical induction question, most of the student get it wrong during the algebra part. Dia careless kat situ. Waktu dia nak expand, dia nak factorize, dia careless. Most of the time, that was the problem. I would like to show some of the problems you might try and you might ignore. For example, for this one, 5 dengan 6 boleh buat tapi dia susah sikit. Untuk test kamu dengan final exam kamu, selalunya saya buat sum. Selalunya saya buat sum. Yang ni selalunya saya tanya untuk assignment. Because this is a very hard question that requires a certain time to answer it. Dia perlukan masa yang lebih. Boleh jawab tapi perlukan masa yang lebih. Aduh, terkono juga. Oh, negeri 9 rupanya. Okay. So, boleh cuba dan cubalah. Saya pun tak tahu boleh bagi soalan lain tapi bukan soalan test lah. On your own time, try to answer number 2 and number 4. And in the internet sources as well, there are many sums. For example, there is also a sum of even numbers. 2 plus 4 plus 6 plus until 2k equals to n times n plus 1. You can also try that. Alright, happy trying. If you don't have any question for the time being, we will take a break for a short while before we go to introduction of sets. Okay, lihat sebentar.
끝자락 잡겠다고 저 높이 두 손을 뻗어봐도 다시 캄캄한 이곳에 light up the sky 네 두 눈을 보며 I kiss you bye 실컷 비웃어라 꼴좋으니까 이제 너의 하나 둘셋 How you like that? Plain drink, get hydrated, don't let me that's so you like that. Go come from money, cause they shine like the stars. 그 미소를 띠며 I kiss you goodbye. 시간 비웃어라 꼴좋으니까 이제 너희 하나 둘셋 How you like that? You gon' like that.
Siapa Syilama? Oh, K-Click. Oi, tajuk dia K-Click terus. Baru tahu. Okay, saya bukannya minat Blackpink. Tapi sebab ramai orang minat Blackpink, saya pun dengar lah kenapa sedap kan. Siapa ni? Nak cakap apa? Muhammad. Oh, tertekan ke? Tak apa. Pasang lagu JB. Aduh, baik lagu JB. Siapa JB? Ashibah. JB tu benda. Saya tak kenal JB. Justin Bieber. Oh. No. Berani. Jom. Baru tahu. Lampi sikit sebab Justin Bieber. Sorry. Saya tak benarkan Justin Bieber punya suara dimainkan dalam handphone saya. No, cannot. Adalah. JB ada yang okey lah Mesti korang tak tahu saya minat lagu benda kan. Siapa dapat teka memang terror lah. Salah, come on lah. Slipknot salah, 1D, One Direction salah. Korang ni, tu yang beza. Seminat J-pop, no. Rock kapak spesifik sikit. Okay, actually BTS, Bang New Boys pada lutut. Oi, nice. I like bukan, last kali anak PA saya jawab, memang saya suka. Red Hot Chili Peppers. Antara band yang sepernah saya jamming dulu lagu dia orang. Scorpion, yes, good. Metallica, U2 no. U2 okay lah tapi tak main lah. Saya minat banyak lagu yang sedap. Lagu zaman sekarang mana yang sedap? Contohnya antara artis yang berbakat, saya rasa yang betul-betul berbakat pada zaman sekarang ini, artis Malaysia yang berbakat, yang memang saya follow sekarang ni, mungkin korang tak sangka ialah I Am Nita. I Am Nita dari segi suara, komposisi muzik, kelebihan dia bermain alat muzik, saya rasa sedap. Memang sedap. I Am Nita salah seorang. Saya peminat nombor satu, saya memang minat. Tak payahlah, tak penting. Alright, I think the break is over. Okay, nantilah bila habis kelas saya pasang lagu lain lah. Termasuk saya rasa macam DJ je. Green Day saya minat juga, but not all song, thank you. Dah lah, cukup lah. Semua saya minat. Kecuali JB. JB tut. Tak adalah benci sangat JB Okay lah JB. Imran Khairul left the meeting. Okay, bye. Alright, kita masuk kepada set. Set ni adalah nota yang saya tak convert kepada modular. Ini nota ni saya buat sama-sama dengan Dr. Syam. Dan sets adalah benda yang sepatutnya korang dah tahu. So hari ni kita cover several things and then I will include the new things that you not encounter before during your school level. Okay, saya buka sekarang. Right, ini slide OCW saya. Okay, kita untuk modul 2 ni dia ada set, function and relation. Relation tu langsung korang tak tahu, yang tu saya kena ajar slow-slow. Okay, set is simply just a collection of elements. Is how we represent the elements. And the elements can be in two forms. Dia set builder ada dengan roster. So contoh kalau roster notation, roster ni boleh kita sinonimkan dengan list, list number. So if I put this, let's set A equals to 2, 4, 6, 8. Okay, ini adalah set yang mempunyai elemen even numbers from 2 until 8. Very simple. Ini roster notation. Certain fundamental things that you must know is that the set might not be in order. It can be 4 first, and then suddenly 8, 6, and then 2. If you represent into the second form, it's still the same set. Set is not compulsory for you to be in order. However, normal people will always like to arrange things in order. However, for the set notation, there is no problem if you jumble the order. And it can also be repetitive. So for example, if I put 4, 4, 4, 8, 6, 6, 2, it is the same set again. If you repeat the element, it still counts as 1. Okay? There is some problem with roster notation, by the way. Because roster notation, if the number of elements is finite and many, then the list will be quite long. Therefore, a set builder notation is much more common. So for this particular same example of elements, set builder notation is much more elegant. You can represent it as like this x, and then you put the condition x is even, and x you put the value from 2 until 8. So this is still the same set A, just a different notation. And again in set builder notation, macam contoh condition ni, ada setengah student kata boleh tak dia tak mau tulis x is even, dia tak mau tulis julat macam ni, dia nak tulis x is even, dia lebih besar daripada 1 and kecil daripada 9. Pun boleh, dia sama juga. The representation of set builder is sometimes also not necessary, because when you try to generate from this notation as well, dia akan dapat 2, 4, 6, 8 juga. The skills that is necessary for you guys to master is on how to convert roster notation into set builder, and also vice versa, you need to convert set builder into this one, roster list. Yang tu kena mahir. So for example, a very simple one, ini dah ada jawapan. Boleh tak kita sama-sama buat contoh yang saya terus bagi? Okay. Apa tu? List the elements. List all the elements of set B such that I give B like this. X is prime, and the second condition is that X less than equal to 12. What will be the element of B?
Two, three, 5, 7, 11.
Thank you. Very simple. So, Musin yang jawab tu, saya tak ingat. Okay, Musin kot. Tak kisahlah. The student yang menjawab tu, 2, 3, 5, 7, 11, you are correct. If there is one more student who said to me, can I answer 7, 5, 11, 2, 3? Also correct. If one more student answer like this, 2, 2, 2, tak pasal-pasal dijawab 2. It can also be correct. Because set, again I repeat, it might not be in order. It can be in order, tak semestinya dalam order. It can also be repeated. But normal people will answer the first one. Ada saya jumpa student yang jawab macam ni dulu. Senior-senior korang. Saya kena kira tak? Okay. So set notation, simple. As long you know how to represent it. Okay. This is Venn diagram popularized by the mathematician named, actually his name is Venn. It's a diagram which show a logical relation between a collection of sets. And the set must be finite, so it's bounded within the diagram. And the Venn diagram usually dalam bentuk circle, but it's not necessarily must be in circle, as long you show it in form of visual diagram. In set, there are various operation. Saya mulakan dengan yang equal. For B just now, I think I already covered this key point. Just now I already said it. 2, 3, 5, 7 just now. If you repeat, you jumble it up, or you repeat it, 2, 2, 2, 3, 3, 5, 7. All of these are equal to each other. As long it has the same element regardless of the order and also repetitive. Semua ni adalah sama. Jika saya letak A sama dengan 3, 5, 7, 7, 7, 2. So A is still equal to B and vice versa, B is also equal to A. As long it has the same element, saya ulang sorry kalau boring, regardless of the order and also repeated elements. Okay, very simple concept here, the equality of sets. Now I will go to a little bit hard concept, which is a concept of subset. In discrete mathematics, you must master the definition again. And suppose you have two sets, A and B. And A is a subset of B if and only if, you dah belajar logical connective, if and only if every element of A is an element of B as exhibited in the diagram. So if I put A equals to 1, 2, 3, and B, I put it as 5, 4, 3, 2, 1. is A a subset of B? The question is true. Because all elements in A is in B. The keyword here is all. You must check that 1 is here, 2 is here, 3 is here, not the other way around. Kalau the other way around, for example, maksud saya ialah B is not a subset of A. Because of what? Because 4 is not an element of A. You can also put 5 is not an element of A. If B is a subset of A, all element of B must be in A. But in this particular example, that is not the case. From the definition of subset, two properties emerge. Which is the first one is that empty set must be a subset for any set, and also the set is the subset of itself, number 1 Roman and number 2 Roman. Subset, konsep dia, A is a subset of B if and only if every element of A subset is different with proper subset. Ada perkataan proper di sini. And the notation of a proper subset is B. A proper subset of B. If A is a subset of B and there exists at least one element of B not in A. Okay. Definition ni ramai student keliru. Sekejap. Okay. Ramai student keliru. So, izinkan saya untuk perkenalkan konsep ni bersama-sama. Okay, set equality. Okay, for inequality, you tahu ini apa and you tahu ini apa. So, dalam konsep set, dia hampir sama. Equality dalam konsep ini inequality, inequality. AB. You apply dalam konsep subset. If A is less than or equal to B, it can be either less than or actually it can be equal. But not for the case of A less than B. It must be strictly smaller than B. Dia mesti nilai dia lebih kecil daripada B. Dia tak boleh sama. This concept also applies almost similar to the concept of subset and also proper subset. For the concept of subset, A can be the element as long as it is in B. It can also be equal to B for the concept of subset. However, for the proper subset, it must be subset of B. All elements of A is in B. And it must be significantly smaller than B. There is at least one element of B which is not in A. So, let's look at the previous example. Yang mana saya dah padam. Saya tulis balik. Okay, A just now is 1, 2, 3 and B is 5, 4, 3, 2, 1. A is a subset of B clearly because all element of A is in B. A is also a proper subset of B, because A is a subset of B and 4 is not an element of A. It must be at least one element of B which is not in A. So if you try to apply inequality concept, A is significantly smaller than B. Okay, I put one more set A, B, C, D. And this time, D, I assign it as 1, 2, 3, 4, 5. For this case, it is clear that D is a subset of B, because all element of D is in B. But D is not a proper subset of B, because there does not exist one element of B which is not in D. Kalau you pening, always fall back to the concept of inequality. Okay, boleh baca sekejap yang kiri ni. Dulu saya tak buat slide yang ni. Kerana ramai sangat pening, saya buatlah. Dr. Syam tak suka slide yang ini. Dia kata, mana boleh explain math macam ni. Tapi saya terpaksa. Okay. I don't open to question yet. I think this is fairly, you try to understand first. The example comes later. Yang ni boleh skip. Okay, ada student risau. DMA student, not you guys. You DMS. For DMA, budak computer science belajar tu, proving di chapter 4. And I think I already mentioned to you guys and girls is that proving exists in all chapter. Okay, so untuk diorang, kadang-kadang proving tu bukannya saya tanya even and odd saja. Saya tanya untuk number theory, saya tanya untuk set. Tapi untuk DMS, sebab proving bermula di chapter 1, saya tak boleh tanya proving untuk number theory lagi. Itu beza dia. So kamu jangan risau untuk soalan begini. Tetapi saya suka tanya soalan macam ni. Mungkin saya boleh tanya dalam assignment, saya boleh tanya dalam final exam. So be careful lah. Tapi jangan risau sangat. Proving exists in every chapter. Even chapter logic pun ada. Logic pun ada proving. Okay, finite and infinite sets. This one is very simple. Finite maksudnya you have a countable elements. You boleh kira. Walaupun di besar mana pun, di banyak mana pun, you still boleh kira. Dia ada the n number there. N element, the starting element and the last element. For infinite, you contain possibly uncountable elements in there. So obviously, for this example, if O is a number less than 10, is a natural number, positive integer less than 10, so it will be a 1 until 9. You can, this is a finite case. If I just define it as O is a set of positive integer, let O be a set of positive integer. Kalau positive integer ada banyak, so it will be banyak, starting from 1, 2, 3, 4, blah 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 blah. Prime number is infinite. So a set of prime number is also uncountable, is infinite. Okay. Okay, ni saya kena slow-slow. Cardinality. cardinality represents by the symbol of modulus there. Is the number of distinct element in A. Okay, so B just now is 5, 4, 3, 2, 1. And suppose if I define the set E as 5, 5, 5, 5, 5, 4, 4, 4, 4, 3, 3, 3, 2, 2, 1. Ambil kau. So what will be the cardinality of B? Is just the number of distinct element. Distinct berbeza, distinct, a different element of B. So B contains 5 elements. And E also 5. You count the repeated element as one time only. And apparently for this case, ada juga yang saya boleh nampak kat sini. B equals to E. B is a subset of E and E is a subset of B. So if B is a subset of E and E is a subset of B, then B equals to E. The set is equal if it is a subset among themselves. B is a subset of B and E is a subset of B, then B equals to E. And by this visual diagram as well, you can see that this is the same. Nampak tak sama? Tetapi sebenarnya sama. Regardless of the order and repeated elements. Ada soalan setakat ini? Okay, still okay Okay. Cardinality of empty set of course is 0. Empty set, the cardinality is 0 because empty set does not contain any element. Okay, ini saya tak perlu tunjuk dulu. Okay, kita masuk sikit je, saya nak tengok sampai mana. Collection of set ni nanti dulu, complement, disjoint. Okay. Some of the elements that you need to remember, which is the operation of set. Some of them you are already familiar. Union, it can be either in A or B. I will show a very simple example first for you to recall back. Suppose it will be 2, 3, 5, 7, 11. And B is, I will use the same example for the remaining operation. 0, yeah. Cukup lah dulu. Okay. Find A union B. Find A intersect B. Okay. A union B is an element which is in A or B. So you must include every possible element in A and also B. Therefore, it will be -4, -2, 0, 2, 3, 4, 5, 7, and also 11. That is the concept of union. Different with that is intersection. Intersection is that the common elements between A and also B. So the common element between A and also B ada tak? Ada, which is 2. Yang ni saya simplekan dulu, saya akan ulang balik lah lepas ni, especially for the collection of sets. When we talk about a complement, complement ni best. A complement, you must have a universal set. You cannot talk about complement if you don't have a universal set. Suppose your universal set I define as X is an integer. I define it from a -20. Besar sangat ke? -12 je lah. -12 up until 12, and X will be integer. Okay. My question is very simple, is that find the complement of B. Complement of B is basically the elements which is not in B. It's an element X not in B, but still in the universal set. It satisfies two conditions. It must be in the universal set, but just not in B. So for this example, I already defined the universal set. So the B complement is what not in B. So semualah yang bukan dalam B. -12, -11. -5, -4 is in B, so you don't write it. -3, -2, -1, 0 ada, 1, 2, 3, 4, 5. Ni 6, 7, 8, 9, 10, 11, 12. Please make sure you don't leave out any elements. Dalam soalan set, make sure you list down all the elements. Okay, cukuplah complement of set disjoint. Disjoint pun sama. Disjoint if there is no common element, if there is no intersection. Hence, the intersection of A and B is a null set or empty set to concept disjoint. Okay, cukup dulu sampai setakat ni. Ke saya nak satu lagi? Ni KIV dululah. Ni saya sambung minggu depan. Esok saya habiskan function ya. Okay. Before we end the lecture, I would like to give one question for you guys to answer. To test your understanding for today's lecture. So, I define you jelas tak? Okay, Z positive integer. Suppose my universal set is defined as this, and A is a subset of U, and B is a subset of U. Okay. A is given as this element, Y, and Y is even. Okay. For B, Z is not prime. I want you to find to me, for me, what is A union B? And the second one, what is the cardinality of A intersect B? In 3 to 5 minutes. Nampak senang, tetapi selalu student careless mistake. So I don't want my students to careless mistake. Can I add one more? Find the B complement as well. Sama dengan. Okay, saya tengok chat just in case kalau ada yang. Okay, Leong Tengman, cardinality of set of an empty set. Sorry ya Leong, tu saya cakap saya tak tengok chat bila saya present penuh. Okay, Leong, cardinality of set of empty set, is it equal to 1? Empty set contains no element, therefore it's equal to 0. There is no element. Cardinality is a number of elements, right? So as empty set contains no element, therefore it is equal to 0. Okay, sama juga macam tadi. Kalau dah dapat, saya nak tengok jawapan student. After I check the answer, then we can end the lecture. Kawan-kawan, soalan ni agak senang. Ada yang kirakan WhatsApp. Tolong WhatsApp. Thank you. Ada yang jawab? Okay, mari saya check jawapan Mohsin. Ya, saya tengok jawapan Mohsin. 6, 8, 9, 10. 1, 2, 4, 6, 8, 9, 10. Yeah, after this, the student please, like I said a couple of times, why not just post in the group, boleh tak? Bagi benefit orang lain juga. Okay? Lepas ni kalau saya tak layan, jangan tanyalah kenapa. Kita nak have a good discussion, that's why I do the group. Thank you. I hope you understand. All of you are a very intelligent student and you should understand my simple instruction. Melainkan kalau hal-hal personal. Okey, jawapan Muhsin ada problem dekat nombor 2. Nombor 2 dia cakap cardinality of A intersect B. So Muhsin hati-hati check balik. Okey. B tu soalan nombor 2 tak betul. Cardinality dia bukannya suruh minta kita list down element. Alright. Alpha memberi jawapan di sini. Okey, cukup dulu. Saya tengok seorang-seorang kejap. Kalau tak banyak sangat. B 2357 betul. Alpha A intersect B 2, 4, 6, 8, 9. Alpha betul semua soalan. Okey, cukup dulu hantar. Akram, baik, jawapan lain dengan alpha. Yang mana satu betul ni? Banyak yang cardinality tu tak sama Saya tengok balik. Okey, Akram cek balik nombor 2 sebab alpha dapat 4. Aisyah pun dah dapat 4 untuk cardinality. Imran Khairul 4 juga. Nanti saya cek Muhsin tak apa, it's okay. Syaza, Tania sama setakat ni dengan kawan-kawan yang lain. Dan Tasha sama dengan kawan-kawan yang lain. Okey, so saya lihat kat sini. Bukan ramai lah. Okay, all of you, when you want to show, to find the answer in this, usually you convert this into a roster first, right? Itu yang saya nampak semua buat. Kerana dia mudah nak kira. So A, you list down the element of Y there, Y is even, so it will be 2, 4, 6, 8, 10. 1 tidak termasuk, 0 tidak termasuk. Okay, for B, is not prime. Ni sedikit pening, tapi tak susah. 1 is not prime. Mungkin ada yang tersilap kat sini. 1 is not prime, 2 is prime, 3 is prime. So the next element will be 4, 5, 6, 7, 8, 9 and also 10. Okay. A union B tak ada masalah, semua saya rasa 1, 2, 4, 6, 8, 9, 10. Okay, saya rasa sama. Saya buat balik je, saya cuba tengok sama tak dengan korang, sama. Okay, we glad, I'm glad that you will the same. For the number 2, be careful, it asks for cardinality of B. However, you should find A intersect B first, so this will be still quite simple I suppose. 4, 6, 8, 10. So saya rasa Akram kot tadi, dia kira lain kot. Cuba check balik And the cardinality. Tak apa. Tak apa. So it will be 4. Sebab tu kena student buat, saya nak tengok student buat. Bila student buat dan saya menjadi saksi diorang buat latihan, barulah kita nampak kesilapan dia. Mana yang selalu dia silap, dia tercareless ke apa kan. So B complement, so you just compare with the universal set, what's not in B but still in the universal set. 2, 3, 5, 7. So because this is not prime, this will be a set of prime number less than or equal to 10. Alright, I think that sums up the lesson for today. Set ada lagi, tapi minggu depan kita sambung. Esok, okay, saya tutup je Esok kita akan belajar pasal function. kepada yang masuk bridging. Kepada yang tak masuk bridging, don't worry, I will share the slides and also I will share the videos. However, the slides is function and graph, so saya masukkan sampai graph. Tapi untuk korang ni tak adalah sampai kena lakar graph pelik-pelik lah, sebab kalau dia terjadi terlampau banyak. Okay, as long you have the knowledge, you can benefit from that. Okay, is there any question before we stop?
So, yang graf tu semua graf yang apa? Ada apa? Yang cubic semua tu
Yes. Ada. Musin, untuk function and graphs, saya akan masukkan beberapa graf asas. So graph linear equation, graph quadratic, a cubic, a rational function also saya akan letak. Function banyak kat dunia ni, tetapi kita akan masuk yang sikit-sikit asas. Ya, saya akan masukkan. Soalan lain? Alright, sama Musin. Soalan lain? Okay, kalau tak ada soalan, again, I would like to remind you all bahawa test akan dijalankan pada waktu kelas. The test will be held on the next week, Tuesday. Make sure you attend at the time. And also you have a good internet connection. Try to get as best as possible. And jawab attendance hari ini di Google Classroom. Okay. If not, I will end the lecture today. We have quite a moderate good section for today. Kita habiskan dengan let's begin for soalan. Okay, thank you so much. I will stop recording now and have a good day.